Now the last topic from this chapter is inverse of a function. Inverse of a function. Let f from a to b be a bijective function. Be a bijective function. Already we have discussed with the bijective function. Bijective function is nothing but 1 1 and onto function. F is 1 1 function and f is also a onto function. Now then the function g from b to a which associates each y belongs to b to a unique x belongs to a such that f of x equals to y is called the inverse of f and is denoted by f inverse. See student, we'll read it again. Let f from a to b be a bijective function, that is 1 1 and onto function. Then the function g from b to a, means reversely we are defining the function a to b and b to a. G is b to a, which associates each y belongs to b to a unique x belongs to a. This is very very important students. See, when the function f is 1 to 1, so the different elements are having different images. It is clear? Now it is onto function, means there is no any element in the codomain set such that it is not having any its pre-image. Okay, means all are having its pre-images, means the element from the b can have more than one pre-images. But the function which is we are defining reversely, b to a, which associates each y to a unique x belongs to a, means if in the function f we'll consider b and a, so in that case b is also elements from the b set are also having only one pre-image when we are defining the function g. Getting? So which associates each y belongs to b to a unique x belongs to a, means this g is also 1 to 1 function. Getting? Now clearly g will be the onto only, because here we have defined f as a function, so all elements are having unique image in b. So clearly all elements are having unique pre-image in b here in the g function, so it is clearly onto, and from this statement we have defined it as a 1 1 function. Okay, such that fx equals to y, it's called the inverse of the function f. Means whenever the function will be there a to b, its inverse will be always defined from b to a with this condition. Getting? And it is denoted by f inverse, or we are writing inverse of a. Getting? We'll write one remark here. See student, when f is a bijective function, then only we have defined its inverse. So we can have one remark that f inverse exists only if f is a bijective function. Okay. Now we'll take one example for the inverse of a function. Example 1. If, it is very easy, if a equals to 1, 2, 3, 4. Set A is having 4 elements. Then set B equals to 2, 4, 6 and 8. F from A to B is given by f of x equals to 2x. Write f and f inverse as a set of ordered pairs. Okay, now what is given? F from A to B by fx equal to 2x. So f will be the set having first element 1, 1 into 2 will be 2. Now second element 2, 2 into 2, that will be 4. Third element 3 into 2 will be 6, and the fourth one 4 into 2 will be 8. All elements are there. So if we draw the Venn diagram, it will be 1, 2, 3, 4, and this is 2, 4, 6, 8. 4 to 8, 3 to 6, 2 to 4 and 1 to 2. Clearly it is a 1-to-1 function. Then all elements are having pre-images in the codomain set. It is an onto function. So it is a bijective function. So it is bijective function means f inverse exists. Okay, so what will be the f inverse? You write this order pair reversely. So it will be 2, 1, 4, 2, 6, 3 and 8, 4. Understood? So your answer will be f equal to this and f inverse equal to this. Any doubt? Now we'll consider one more example. Example number 2. Let f from R to R be defined by f of x is 3x plus 5. Prove that f is a bijection. Find f inverse. Okay, now to prove f as a bijective function, we need to prove f as first 1-1 function and second onto function. Okay, now first 1-1 function. Let x1, x2 belongs to the domain set R. F is defined over the set of real numbers, so we can take x1, x2 belongs to R. Let f of x1 equal to f of x2. So what is the function? 3x plus 5. So it will be 3x1 plus 5 equals to 3x2 plus 5. We can cancel 5 from both the sides. So what we will get? 3x1 equal to 3x2. We can cancel 3 also. So what we are getting? x1 equal to x2. So clearly f is a 1-1 function. Okay. Now the second, to prove onto function, let fx equals to y, both x belongs to R, that is set of real numbers, and y belongs to set of real numbers only. This will be from codomain set and this will be from the domain set. What is the function? 3x plus 5 equals to y. We will write the x in the expression of y. So what will be there? 3x equals to y minus 5 and x equals to y minus 5 by 3. Okay. Now that is, this x belongs to set of real numbers, that is corresponding to each y, that is corresponding to each y belongs to the codomain set, that is a set of real numbers. There exists y minus 5 by 3 belongs to R, that is the domain set, such that f of x, that is, what is x now? F of y minus 5 by 3 equals to y belongs to R, that is the set of codomain set. Okay, so this is true for all y belongs to R. So f is onto function. So f is 1 as well as onto function. So clearly, therefore, f is a bijective function. So therefore, f is invertible. Getting, whenever the f is bijective, that time only we can define the inverse of function f. So f is invertible function. Thus, we define f inverse from R to R. Now domain and codomain are getting interchanged defined by f inverse of x. Now see student, whatever we have taken, f of y minus 5 by 3 is y. So this will be element in the domain set of f. Okay, so this will be f inverse of x will be x minus 5 by 3. Getting? So this f inverse x, now this x will be the domain, this x will be from the domain set of f inverse. But now in this function, this will be the y, this y will play the role for x here. Getting? So now this x minus 5 by 3 will be in the domain set of f. Getting? F inverse equal to x minus 3 for all x belongs to set of real number. See student, when we are defining f from R to R, here x is f of x, that is equals to 1. And when we are defining f inverse, so f inverse of y, when we are taking x equals to f of x, a function in x. So here when we are defining f inverse, now this will be the y element. So f inverse of y will be here. Getting? F inverse, here we are writing y. So f inverse of y will be here. So x equals to f inverse of y. Getting? So whatever the value of x will be there, that we have to write in the form of y. As we have written here, no, x is y minus 5 by 3. So here that's why we have taken f inverse of x is x minus 5 by 3. Understood now? what is the bijective function, what is the invertible function, and how to define the F inverse. Getting?